Just so everybody knows, I have an alarm set up. Not important. I have an alarm set to remind me at 3:50 that we've got 10 minutes so that we don't go overtime. The first day here, they had a band coming in, and I went a couple minutes overtime, and they were polite. They didn't say anything, and I asked them if I was in their way, and they said, "Oh, no, go ahead and do what you're doing." So no problem, but I just out of politeness, I don't want to be in anybody's way again. But anyway, so technician, can't remember if I started the recording. I did. All right, so more antennas and feed lines, and I think this is the last antenna and feed lines segment. Feed lines, so we're going to talk about connectors now. So we've talked about the antennas, we've talked about the feed lines, how to get from the antenna back to your radio, and now we're going to talk about how they connect on both ends. A lot of these that you see here are the female and the male connector are still called the same thing. So SMA and BNC, they're the same. The type N, it's still called a type N, whether it's the female end or the male end. But for one odd reason or another, with the what's called a UHF connector, but is really a VHF connector, they've separated them. The female end has one designation and the male end has the other designation. The male end is what you would typically find on the coax cables. The female end will be what's on your radio. You know that because the female end that's on your radio has a socket in the middle, and the male end will have a pin in it. And I'm not going to explain it further than that, as far as why they're called male and female. Okay, but your PL259 is the male end that will typically be on the end of your, and here's the thing, PL means plug, SO means socket. So you always know. So PL259, the male part, is the part that's on the connector or on the ends of the coax. Now you can get coax terminations for SO239, and I've got a couple of them because it worked for the application that I needed it to work on. But anyway, there's various different types there. The SMA is typically high frequency. Does anybody... You were IEEE, you're IEEE, right? So you all probably know what SMAs are. Okay. So, yeah, the SMA is a tiny little brass connector, and that's what the VNAs have, right? Yeah. So, N-type is more expensive, but it's also more weatherproof, they say. But PL259 is the most commonly used, along with the SO239. And did we ever come to the conclusion? No, it's not. Yeah, so this is not to scale. So it is just a good picture that shows you what each of them look like. So the N-type right here and the SMA are really, yeah. Whereas this one here is probably a little over half an inch, probably close to 3/4. But anyway, and then you see the BNC right there is what most of the stuff in my shop when we're connecting test equipment is what we're going to use. And that's your UHF right there. And you'll notice it says up to 300 megahertz. What ends at 300 megahertz? UHF ends at 300 megahertz. So this is actually for HF and VHF, but it's easier to build. It's easier to terminate a coax with that than it is with an N connector. So most people go ahead and use it. Yeah, they're significantly, yeah. So anyway, the N-type or the UHF, when you use that for your UHF, equipment, even though it's a better bet for VHF, the point of fewer connectors in between the radio and antenna becomes even more important. So you don't want to have any more than absolutely necessary. Which of the following is true of PL259 type connectors? Commonly used for HF and VHF frequencies. And actually UHF too, but yeah. Which of the following RF connector types is most suitable for frequencies above 400? Now, which one is most suitable for frequencies above 400? B, type in. I'm glad you said that because I couldn't remember if I covered that or not. So coax cable connectors can be difficult to install properly. And I will tell you now, I mean, I've been at this, I joined the Navy at 18 years old, fresh out of high school. Went to school for all of this, learned how to build these connectors and everything. So to me, it seems like second nature, but the first time you build one, and to give you an example, the first time I got the SO239 terminated cable with, and the reason I wanted to do this was, you know, the input on the radio and the input on the antenna box is an SO239, so use a coaxial with a 259 to connect to it, but then the cable that you connect from the choke to the radio, again, it has to be, you know, the cable is going to be a 259 both ends. So the one end of the choke that I built, I put a 239 on it. So it was just like connecting to the radio at that point when I connected the cable to it. So can be difficult to install properly. And I thought I had it all down, but I did go through, I bought a 5-pack and it took me 3 of them to figure out how to do it properly. So I ended up with one left over afterwards if I decide to build another choke. A frequent cause of feed line failure is high SWR, and you can get high SWR for a number of different reasons like we already discussed. Make sure that your coaxial connector are crimped or soldered properly. Now, if you're soldering them, the problem that, well, you know, you're still going to have to solder the pin. You have to solder the pin to the center conductor. You're not going to get away from that. But make sure, let's see, your crimp, if you're using the right size jaw and the right size collar, when you crimp it, it should be good because your crimper's not going to release until you reach the point where everything should be locked into place. And then you want to, building these up, you put all your stuff on the cable first in a reverse order that you're going to install it back to the connector. And so the last thing on there would be some heat shrink. And then you slide the heat shrink over the end when you get it done and seal it down so that it locks everything and seals everything up. But for soldering, some of the connectors and stuff that you buy on Amazon, they don't like to take solder. And the second part of soldering is, even if they do like to take solder, you have to get them hot first. As a kid, when I was trying to solder parts together without any training, I thought all you had to do was get the solder hot and then it would all stick. But that's not necessarily true, because what you're soldering to and the item that you're trying to solder to it, they have to be hot too. You have to get the solder to flow on there for it to take. And a lot of the stuff that you buy on Amazon, the insulated part in the center of the connector is too soft. And once you get it hot enough that everything actually flows and takes it, then everything's out. Your center pin basically is going to be out of line, your center pin or socket. So if you do that, it's a good idea to put them together. So you take a 259 and a 239, put them together, and then solder them on the inputs to the connector while everything's in place, and it'll hold it there. And then that way, when you take it apart, it's still centered. So that's the way to do that. Loose connections can cause high or erratic SWR. So if you don't get your crimp on there tight enough, or you don't get your solder to flow and seal up, then the slightest little bit of movement can cause change in your SWR and cause problems. Verify solid connections with one another. So as much as I hate to say it, when you get it all soldered together and everything cools down, give it a little tug. If it comes apart, it wasn't done right. Might take a little bit more. Okay. What can cause erratic changes in SWR? B, loose connection on the antenna or feed line. Standing wave ratio and antenna measurements. Standing wave ratio, or SWR, and you'll also sometimes see this as VSWR, voltage standing wave ratio. I think that's going away for the most part. At least I haven't really seen the VSWR since school. Is a measure of how well an antenna is matched to a transmission line. So the maximum power transfer will occur when everything is equal. So if you got 50 ohms and 50 ohms, you'll get the most power transfer. The SWR of a perfectly matched antenna system will be 1-to-1. And SWR of 1.5 to 1 or less is generally considered acceptable. Most modern radios will have a safety in them, and when you hit that push to talk button, if it's over 3-to-1, it won't let you transmit. Or if it does, it'll greatly reduce your power so that you, basically it saves your finals. SWR of 3-to-1 or greater can damage transceiver output stage. So yeah, you don't want to, especially on some of these nicer radios these days, you really don't want to damage the finals because repairs can get expensive. And the whole time that it's being repaired, you're without a radio. Okay, so SWR, this part is not on the test. This is here so you can see where it comes from. E maximum over E minimum, and it's equal to I maximum over I minimum. So remember, E is voltage and I is current. The larger number will always come second, no matter where it's at. So SWR Z load over Z0, or Z0 over Z load. And the line in the middle is your ratio. Usually you're going to see it like you would see it expressed right over there on that right-hand side, 1.5 to 1. So that's normally what you would see. I got my 10-meter dipole, I think I got it down to like 1.21 to 1, and was thinking about going further, and this was after cutting my first set of radials down too short, my first set of radiators down too short, and then thought about putting more on there. Said, no, I'm just going to start again from scratch. So when I got down to 1.21, I think it was 1.2 or 1.21 to 1, I said, you know what? I think I'm just going to stop here. So I didn't push it any further than that. What is standing wave ratio? Measure of how well a load is matched to a transmission line. I'd say that's correct. Yeah, the question specifically asked for ratio, so you did good by answering A, not letting that ratio in that answer misdirect you. What reading on an SWR meter indicates a perfect impedance match when between the antenna and the feed line? Perfect impedance match. C, 1-to-1. What does an SWR reading of 4-to-1 indicate? D, an impedance mismatch, and your transmitter is probably not going to let you transmit. At least most of the modern ones won't. Standing wave ratio and antenna measurements. The SWR will be low when there is a good impedance match. SWR will be high when there is a bad impedance match. When SWR is low, signal losses are low. There are other things that can cause signal losses, right? But this one here is controllable by us. When the SWR is low, signal losses are low. When the SWR is high, more power is lost and the transmission line gets radiated out as heat. An impedance mismatch causes power to be reflected back from the load. There was a Navy training film called Standing Waves on Transmission Lines that you can't even find on YouTube anymore because it's considered inappropriate. But for decades, the Navy used it to train electronics people what SWR was. So anyway, it dealt with, they explained how the reflected part works, because you get out to your antenna and there's a mismatch. Some of the power goes into the antenna, but some of it gets reflected back. And it's that reflected back power that causes problems with your finals, which was much less of an issue when you had tubes. Solid state, can wreak havoc. Less power to the antenna, less radiated power. High SWR. So the SWR gets out of control. You get less power on the antenna, and the less power you get on the antenna, the less gets actually radiated. And this kind of shows blue is your original signal. The black one is your standing wave and your reflection. So you get out to the antenna and something's not right, so some of that comes back. What is the benefit of a low SWR? Benefit of a low SWR. Reduce signal loss. They try to attract you with some of those other answers that look good, right? What happens to power lost in a transmission line? C is converted into heat. Hey Vince, how you doing? No worries, no worries. Standing wave, let's see, modern amateur radio transceivers reduce output power if the actually I've already said that, didn't I? Modern transceivers will reduce the output power or completely cut it off if your SWR is high. This protects your output transistors from being damaged by the reflected power. And it's usually, and I can tell you this is at least an ICOM standard, 3 to 1. So if you're showing up, if you're bouncing above 3 to 1 SWR and you're watching your power meter is going to lay basically flat. The Xiegu, it's been a long time since I got my Xiegu radio and set it up, but I'm pretty sure that it allowed me some leverage to where that trigger point was set. And yes. Yeah, actually I watched a video on that this weekend too, or this week. And I think it was on the 7300 because that's what I bought from Ernie, was a 7300. Okay, so, and that's if you're wondering about how you're gonna, because I thought when I got into this that it would be years before I could afford an HF radio, and then Amazon decided to put the Xiegu on sale for like $400, so I got one of those. And then a year later, one of the guys from the club decided to sell his 7300, which is still top-notch performing radio. And I talked to my wife, and real sweet. And she said, sure, go for it. And then after I bought it, she said, she did like this. I said, what's that? She says, well, you spent $600 on a radio. I need $600 too. So, but she earns it though. I mean, the guy that she works, apparently she works 32 hours a day to take care of this one fellow, and he pays her squat. So she earned it. I learned that. What's that? Yeah. I learned that from my first wife. Somebody asked us while we were standing next to one another if the wife works, and I said no, and she didn't speak to me for a week. So I learned my lesson right then. She has the hardest job in the world and gets paid crap for it. Anyway, modern amateur radio transceivers reduce that power, and it's usually about 3-to-1 where they either reduce or completely inhibit your power. Why do modern solid-state transceivers reduce output power as SWR increases above a certain level? A, to protect the output amplifier transistors. Very good. When choosing an SWR meter, be sure to note the frequency range. And this is important, especially for people just getting started in this, because they find this meter that they like and they go and they buy it and come to find out it's a meter for HF instead of VHF. And it doesn't necessarily work. So be sure that when you pick out a meter, if you pick one out, that you get it for the operating range that you want as far as frequency and power. Maximum power level at which you can use the meter. Using a meter outside of the specified range can result in erroneous readings, obviously. Using a meter above the maximum power level can damage the meter. Some meters measure both SWR and power. A lot of them do, actually, these days. One meter for both functions, SWR and power. There's a couple of examples of SWR and power meters. Which of the following should be considered when selecting an accessory SWR meter? A, the frequency and power at which the measurements will be made. Standing wave ratio and antenna measurements. You can also measure SWR with a directional watt meter. You first measure the forward power, then you measure the reflected power, and then you have to work the formula to get your ratio. Using the two values, calculate the SWR with that formula right down here at the bottom. You should install it in the feed line between, and everybody understands that, right? So output from the radio goes into the meter, output from the output from the meter goes to your feed line, which goes out to your antenna. Which instrument can be used to determine SWR? Delta, directional watt meter. There should be an RF power meter. Let's see. Where should an RF power meter be installed? A, in the feed line between the transmitter and antenna. Let's see. The antenna analyzer can also be used to measure the SWR, and this is what the vector network analyzer, the VNA, that's what it is. I mean, it's really, it can analyze lots of different things in your antenna system. And Bob knows those things a lot better than I do, because all I've used them for so far is to measure SWR. But Bob's done a lot with them. The antenna analyzer can also be used to measure the SWR of an antenna system. The SWR of an antenna system will be lowest at the resonant frequency. And it'll actually show you on the VNA, it will show you a dip. And in that dip is where your resonant frequency is. You can adjust the frequency range that it displays on the face of the VNA. And if you get it small enough, it'll actually flatten out where it'll give you a nice range to where you can figure out what frequencies are good. Some antenna analyzers let you measure capacitive reactance. They let you measure inductive reactance. Is there a way you can do that on the VNA? Can be used as an RF signal generator. I think the VNA does that, because I think that's what, yeah. Right, okay. These capacities may be useful in applications other than antenna analysis. Now this one here on the left, this MFJ antenna analyzer, this has probably been the industry standard for the longest time, but unfortunately The owner of MFJ decided the challenges of keeping the business going were too great, and he was ready for retirement. So they're closing down all of their operations. The one on the right you see there is your Nano VNA. That's the one I've been talking about. These are available, like I say, you can get them on Amazon. You do have to be careful where you get them because some of the copies don't work so good. But I rather enjoy mine. And that one there, on a smaller television, you probably can't see it so well, but that one is set up so that it's got the Smith chart visible on there right now. And that you can get a lot of information from that if you're going to get into, big time building of antennas and feed line systems. Which of the following is used to determine if an antenna is resonant at the desired operating frequency? B, an antenna analyzer. Standing wave ratio, C, if an antenna's impedance, if the impedance of the antenna is not 50 ohms, the impedance at the transmitter end of the feed line will not be 50 ohms. You can use an antenna coupler to transform the impedance to 50 ohms. Antenna tuner / coupler. All right, so this is kind of a misnomer where they call it an antenna tuner because it doesn't actually do anything to your antenna. All it does is present an image to your radio that your radio will like and still transmit into it. So a coupler is is probably a better term to use. This process is called impedance matching, not antenna tuning. So it's just providing, and you'll hear it, like when you press the button on your tuner, you notice that you're off a little bit, so you decide to run the tuning cycle. And when it runs the tuning cycle, you can hear relays switching in there. So they're putting various different inductors and possibly capacitors into the circuit to try to match the impedance so that it will all look good to your radio. And that's the bottom line, is it's got to look good to your radio, or your radio is going to say, nah, let's not do this. Okay, and that is an MFJ tuner. A lot of the modern transceivers will have the tuner built in. So at home, like I say, the first radio I got a hold of was the Xiegu. It's got probably the best internal tuner on the market. I've heard people say, I've never tried it, but I've heard people say you can jam a banana into the antenna jack and it'll tune it. And I don't doubt it. It will tune 10 to 1 and they'll give you. Now, the problem is if you're 10 to 1 and it tunes it so that it will transmit, you're still going to lose that power because there's still a mismatch. All it does is make it look good to the radio. But 3 to 1 or 5 to 1 is where most tuners will work. But most of the modern radios will have a tuner built into them. So I've got the Xiegu, it's got a tuner built into it. I've got the ICOM 7300, it's got a tuner built into it. I've also got a 7000 that was gifted to me by a couple of different people. And the 7000 does not have an internal tuner. So one of the guys that came up with parts for the 7000 so that I could have it also handed me a tuner. And so the tuner, and actually it's one that's designed to work with ICOM, so the cable was easy to get. I didn't have to build it myself. So anyway, that's your antenna tuner. What is the major function of an antenna tuner or an antenna coupler? A, it matches the antenna system impedance to the transceiver's output impedance. Standing wave ratio, C, it's helpful to have an instrument that can simulate an antenna. A device that can do that is called a dummy load. So let's say you need to do work on your transceiver, but you don't there's something going on and you don't want to put it out on the air. So, but in order to transmit, you have to transmit into something, or else it's just going to reflect all back and you're not going to get the result that you want. A device that can do that is called a dummy load. And the picture you see there is another MFJ product called 300 watt dry dummy load. Dry dummy load means it's probably got a series of resistors inside of it mounted to a hard heat sink, which is a huge block of metal, just to dissipate the heat. And you'll see right down there below the input, it says 1 to 650 megahertz. So you do have to make sure that it lines up with your frequency. The other thing you have to make sure it lines up with is your transmit power. You don't want to transmit more power into your dummy load than what it can handle. And another thing that you should look at, somewhere in the specs, it will say how long it's good for 300 watts. You can't terminate, or you can't transmit 300 watts into it indefinitely. Okay. So yeah, it's that last line right there. Okay, so use of a dummy load prevents transmitting signals over the air because you're trying to troubleshoot something. The dummy load is a non-inductive resistor, which means it can't be wire-wound resistors. Wire-wound resistors are inductive. So you have to make sure, and it's mounted on a heat sink. We had a guy in our club do a demonstration of how he took a resonant wire, shoved it down inside of a water bottle and filled it with water and closed it, and he transmitted into it as a water-based dummy load, and it actually worked. I think he said about 17 seconds, the water was getting hot enough that you could feel it on the outside of the cup. But he was able to makeshift a dummy load to transmit into to be able to work on his radio. I thought that was pretty cool. What is the primary purpose of a dummy load? To prevent transmitting signals over the air when making tests. Very good. What does a dummy load consist of? Basic consisting of a dummy load. Non-inductive resistor mounted on a heat sink. There are others. I mean, there's the paint can filled with oil method. That's pretty common. Okay, takeaways. Connectors. PL259 used at HF and VHF. Recommended, but also used for UHF just because of cost. Type N is best above 400 megahertz, so that's what you should be using for UHF, but they're costly and a little bit tougher to build. SWR is a measure of load matched to transmission line. High SWR is caused by loose connections and a few other things. SWR of 1:1 is a perfect match. Low SWR is a good match with low signal loss. High SWR is a bad match and will cause heating in your transmission line. And heat can damage the transmission line if you get enough of it on there. Transmitters reduce power for SWR over 3:1, most of them, in order to protect the output transistors. Measurements, SWR meter, frequency range, and power level. Be sure that, what they're saying is when you pick your meter, be sure you look at the frequency range and power level to make sure you're not going to exceed it. Directional watt meter measures forward and reflected power, and then you have to work the formula to find out your SWR. Antenna analyzer will give you SWR, reactance, and a lot of other things. Matching, your antenna tuner or antenna coupler will match the antenna, will make your feed line and antenna system look like it's 50 ohms impedance so that your transmitter will still transmit. And the dummy load is a non-inductive resistor on a heat sink to prevent transmitting signals when on the air.